Hi everyone. We are off to section 1.4, which is entitled The Composition of Functions. Another topic where understanding it is going to be very helpful for your success in calculus. All right, we do a rule for derivatives called chain rule that deals with composition of functions. Basically, a composition of functions is inputting a function in for x in another function. So f of g of x, fog of x. This little circle in the middle means compose those two functions. And basically what it means is take that second function and plug it in for x in the first function. Okay, so let's do a quick example. Algebraically, if I give you two different functions here, f of x equals 7x minus 3 and g of x equals 10 minus x squared, and I ask you to find fog of 3. So if you read the definition for fog up here, fog of 3 means f of g of 3. So now what we're going to do is we're going to work ourselves inside out. So we're going to do g of 3 first. So this is just a function. G of 3 equals 10 minus 3 squared, because g of x is 10 minus x squared. So that equals 10 minus 9, which is 1. So now I'm going to replace g of 3 with 1. So this equals f of 1. So now the f function, 7x minus 3. So I do 7 times 1 minus 3. So that equals 4. Okie dokie. G of f of 3. Let's do gof of 3. You can certainly do it the other way around. So gof of 3 is taking f of 3 and plugging it in for the g function. Okay? So g of f of 3. Here we go. So f of 3, I'm going to do first. That's going to be 7 times 3 minus 3. So the grand total on that is 18. So f of 3 equals 18. So g of f of 3 means g of 18. So g of 18 is just 10 minus 18 squared. So that's 10 minus 324, which is negative 314. So, whereas adding numbers doesn't matter the order you add them in, right? X plus y equals y plus x. That's called commutative. Addition is commutative, but composition of functions is not. So fog and gof don't necessarily equal. All righty. Let's do another one. I'm going to give you a table. So I have x, f of x, and g of x in a table. All righty. So we're going to go all the way from 0 through 9 for my inputs. So x is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. F of x. So f of 0 is 5. F of 1 is 8. F of 2 is 0, etc. So here's the f column. Alrighty, here is the f column. And then g of 0 is 6. G of 1 is 0. G of 2 is 7, etc. So then I just make these values. Now I can compose f and g as long as I stick between 0 and 10. 0 and 9, I mean. So here we go. I'm going to ask you to find f of g of 3. So same process, except to find g of 3, we're not plugging in to a function, we're looking at the table. So g of 3 here, I go down to x equals 3 right here. go over to g of x, and g of x is 8. So f of g of 3 is the same as f of 8. I go down to x equals 8, and f of 8 equals 3. All right, so f of g of 3 equals 3. G of f of 7. So I go down to 7 on my x, right here. Now I do f of 7. F of 7 is 2. So now I'm basically finding what g of 2 is. Well, that's coincidence. G of 2 is 7. So f and g undid each other with respect to 3 and 7. You can also ask a crazy question like, what is f of 5? So basically, you would find f of 5 first. Go down to 5. F of 5 equals 4. So now this is f of 4. And then go down to x equals 4. And then f of 4 is 7. All right? So have fun. Those are kind of fun. It's like a puzzle. All righty? Another way to do composition of functions is graphically, right? Equations, tables, graphs. We've basically been working with those three items the whole first week and a half so far, okay? So I'm going to give you two graphs, an F graph and a G graph. So I'm going to look at 0 through 5 of both of them. So here is going to be my F graph. All right, going to take some time to draw it. F of 0 is going to be 5. F of 1 is going to be 3. F of 2 is going to be 4. F of 3 is going to be 1. And then F of 5 is going to be 3. So there's my F graph. So this is a graph of F of x. Let's go over here and do a graph of G of x now. So same thing, I'm going to go 0 through 5 on both of them. And so G of 0 is 1, G of 1 is 3, and G of 2 is 2, G of 3 is 4, and then G of 5 is 2. So there is my G of x graph. So now we're going to ask you just two questions on these guys. All right, so the first question I have, what does f of g of 3 equal? So very first thing, I'm going to figure out what g of 3 is, right? So I got to figure out what f of that number is. So here, g of 3, I'm on the g graph over 3. G of 3 equals 4, right? Remember, g of 3 is what is the y value when x equals 3. On the g graph, the y value is 4. So f of 4, what is the y value when x equals 4 on the f graph? My picture's not too good, but it's supposed to be 2. F of 4 equals 2. Alrighty? What if I actually do g of f of 0? So I got to look to the f graph first to figure out f of 0. F of 0 is 5. Now I figure out g of 5. G of 5 is 2. Alrighty? So that would be how to use graphs to do composition of functions. All right. A couple more examples. The next example looks like this. I have f of x equals x minus 8, and I got g of x equals radical x plus 2. They want you to find the domain of f of g of x. Alrighty, so the very first thing we should do to find the domain of f of g of x is to actually figure out what f of g of x is. Alright, so f of g of x is going to be f evaluated at x plus 2. Basically, that means I'm going to plug x plus 2 in for the x in the f function, right? I'm going to plug x plus 2 in for f in the function f for x. All right, so I end up getting square root of x plus 2 minus 8. Well, we learned how to find domain of these radical expressions a couple sections ago. So hopefully you remember, okay, I'm square rooting x plus 2. That means x plus 2 has to be greater than or equal to 0. Subtract 2 from both sides, so x is greater than or equal to negative 2. Function notation, or interval notation, interval notation, domain is going to be bracket, negative 2, comma, infinity, parentheses. So there's the domain of f of g of x. The domain of g of f of x, that's going to be g evaluated at x minus 8. So that is going to be radical x minus 8 plus 2, right? I'm substituting x minus 8 in for that x right there. So x minus 8 plus 2, that's radical x minus 6. All right, so then I have to do x minus 6 is greater than or equal to 0, because I can't square root negatives. X is greater than or equal to 6, so therefore my domain is going to be 6 to infinity. Alrighty. Now there's a tricky devil on this one. Let's talk about that devil. Here we go. I have h of x equals x plus 3 raised to the 8th power. We want to make this into some composite function where f of x equals x to the 8. So they're asking us, what is g of x? What is g of x? Okay? So it looks like I'm plugging in x plus 3 for this x, right? So it appears as if we have to plug in x plus 3 into x to the 8th to get x plus 3 to the 8th. So that expression that we're plugging in ends up being our g of x. So our g of x has to equal x plus 3. All right, that should make sense, because look at h is f of g of x. I'm plugging x plus 3 into x to the 8. That's going to be x plus 3 in parentheses to the 8. So it looks like we got it. All right, one last question and we'll wrap this section up. All right, this is going to be algebraically how to figure out f of g of x given two functions. We kind of did it in that domain example. If I have f of x equals x squared minus 10 and g of x equals 3x minus 5. We want to find a couple things. We want to find f of g of x first. All right, so f of g of x is telling us take g of x, 3x minus 5, plug it in for x in the f function. All right, so this really means the function f evaluated at 3x minus 5. So I replace this x right here with 3x minus 5. So we get 3x minus 5 squared minus 10. alrighty, then we can expand 3x minus 5 squared by foiling or distributing, however you look at multiplying binomials. We get 9x squared minus 30x plus 25 minus 10. So I end up getting 9x squared minus 30x plus 15 is my final answer. So that's f of g of x. Let's do g of f of x. So g of f of x is telling us take x squared minus 10 and shove it in for x in the g function. So that's going to be 3 times x squared minus 10 minus 5. Distribute the 3. Combine the like terms, and we get 3x squared minus 35, final answer. One more. Let's just do one more just for take a peek at what g of x would be. G of x is going to be g of 3x minus 5. So that basically means plug 3x minus 5 in for the x in the g function. So 3 times, replace that x with 3x minus 5, then that minus 5 is still hanging around at the end, right? See what just happened there? I put 3x minus 5 in for that x. Then distribute, so 9x minus 15 minus 5, we got 9x minus 20. Final answer. And that, everyone, is the composition of functions section. Please reach out with any questions you have. Have a great day.